guys, wanted to do a little bit of a review. So just going to pick out 2 questions from the review sheet I thought would be nice to go over. So again, that review sheet is due tomorrow at 9 o'clock. You can either be submitting the Kami file or you can submit images of your work through the Google Doc. I also posted on the Google Classroom page a reference outline for you to fill out. That will not be collected. It won't be graded. I just thought it would be a nice way for you to gather information for the open notes test, so you have one material you can really reference instead of having to sort through all of the information in your books and stuff. Okay, so we're gonna take a look at number 9 on the review sheet. I chose this one because I think there's it's a little more challenging than you realize at first appearance. So we're going to find the area and perimeter of the following figure, which we can see is a semicircle and a triangle. Okay, so it's really kind of, we have to assume it's an isosceles triangle there. So let's start with the area. So let's start with our semicircle. Right, so we know area of a circle is pi r squared. Our semicircle will be pi r squared divided by 2. That 12 centimeters across is really showing us a diameter of 12, which means our radius would be 6. So that'll be pi times 6 squared divided by 2. 6 squared is 36. So 36 pi divided by 2, which is going to be 18 pi. We're rounding to the nearest hundredth, so 18 times pi is going to be 56.55 for our semicircle. And then let's find the area of our triangle. And we know area of a triangle is 1/2 base times height. Base and height are perpendicular to each other. Base is 12, height is 14. Okay. Gives us an area of 84. So our total area, 84 plus 56.55. 140.55 centimeters squared. So we'll put that up there, 140.55 centimeters squared. Great. Okay. So now we transition to perimeter, which is the distance around the outside of a figure. So I'm just going to trace that in my green pen here. So we've got the circumference of our semicircle and then the 2 sides of our triangle. Notice we don't go across the middle. That's on the inside. It's not the perimeter. So we need the semicircle, the circumference of the semicircle, and the 2 sides of the triangle. You might notice we're not given 2 sides of the triangle, but we are able to figure that out. If you look at where the height is in our triangle, it really splits this triangle into 2 right triangles. So if I kind of pull that out here off to the side so we can see it on its own, that right triangle there, we have a leg of 14 centimeters. And then here, this leg up here is going to be half that diameter of 12, so 6. And then our hypotenuse is the unknown. So we can use our Pythagorean theorem, a squared plus b squared equals c squared, to solve for that side length of the triangle x. So we'll do 6 squared plus 14 squared equals x squared. 6 squared is 36. 14 squared is 196. Okay. So together we add those up. 232. Equals x squared. We'll take the square root of both sides and round to the nearest hundredth. 15.23. So now we know the side lengths of the triangle, 15.23, 15.23 over here. Okay. That just leaves us with finding the circumference of our semicircle. So that semicircle again, right? We know circumference is pi times diameter. So semicircle, it'll be pi times diameter divided by 2. So pi times 12 divided by 2, or 6 pi, which is equal to 18.85. So now we'll just add up for our perimeter, 18.85 plus 15.23 plus the other 15.23. Which gives us 49.31 centimeters. And it was really that sort of hidden application of the Pythagorean theorem that I really wanted to go over in this problem. That really makes it a cool, unique problem that we're able to solve. It kind of has that appearance of an older geometry problem, but it really incorporates some of our new topics. Okay. Then I want to go to number 16. Part of my directions got cut off here at the top, so that's okay. We're finding the surface area and the volume of this cone, where we have a radius of 5 centimeters, a height of 12 centimeters, and a lateral side length of 13 centimeters. And the reason I chose for us to do this problem is to look at our different formulas to see which dimensions we're using where. Okay, so let's start with surface area of our cone. And if you reference your formula sheet, surface area of a cone is pi r squared plus pi r L, where our radius is 5 and our L, our lateral side length, is over here on the outside. Okay, so if we substitute, leaving our answer rounded to the nearest whole, so it's going to be pi times 5 squared plus pi times 5 times 13. So that'll be 25 pi plus 65 pi, which will be 90 pi. Again, we're rounding to the nearest whole. 90 times pi, 282.7, so 283 centimeters squared, 283 centimeters squared. Okay. Now we have to find our volume. As we use our volume, the volume formula of a cone is 1/3 pi r squared h. That 1/3 of the volume of the cylinder, we also could have written it as pi r squared h divided by 3. That would have been fine. So we're using the radius again of 5, and then our height of 12. That's our height, RH. Okay, so if we substitute in, we've got 1/3 pi times 5 squared times 12. So 1/3 pi times 25 times 12. Let's see, 25 times 12 is 300, and do a little commutative property. 1/3 times 300 times pi. 1/3 of 300 is 100. So that's going to be 100 pi. We'll multiply by pi and round to the nearest whole, 314.15. So that's going to be 314 centimeters cubed. Okay, so we found the surface area and the volume. Really what I wanted us to highlight here is how with volume we use the height, which is internal. With surface area of a cone, we use the lateral side length, the L, which is that external side length. Few reminders before we get to our joke. Make sure, right, you're working a little bit on that review sheet today, a little bit more on it tomorrow. It's due tomorrow at 9 o'clock. And also working to gather your information for that reference sheet. I really think that's going to make the test a lot easier, having all your information in one spot. Okay, so today we've got our math joke for mathy folks. What do you get if you divide the circumference of an igloo by its diameter? Eskimo pie.